Hey there, welcome back to The Learning Curve. Today we're talking about oxidation numbers, the secret to understanding chemical reactions and balancing equations. Stick around and I'll show you the rules, examples, and even how to ace test questions with them. Let's dive in. First things first. What are oxidation numbers? Think of them as a chemical bookkeeper. They keep track of how many electrons an atom has gained, lost, or shared in a chemical reaction. It's like a popularity contest, but with electrons instead of followers. So why do we care? Well, oxidation numbers help us to balance chemical equations, understand redox reactions, and double-check if our chemical formulas make sense. In other words, they're the secret sauce of chemistry. Okay, time to break this down. Don't worry, it's not as scary as it looks. There are 9 rules to remember, and I'll keep them simple. Rule 1. Free elements. If an element is just hanging out by itself, like O2, H2, or Fe, it has an oxidation number of 0. It's like being single at a party. No gains, no losses, just chilling. Rule 2. Monoatomic ions. For ions, the oxidation number is the same as the charge. So Na plus has the oxidation number +1. Cl minus has the oxidation number -1. It's quite easy. Rule 3. Oxygen. Oxygen is the overachiever of the periodic table. It's almost always -2, except when it's in peroxides like H2O2, then it's -1, or when it's hanging out with fluorine, like in OF2, then it's +2. Rule 4. Hydrogen. Hydrogen likes to mix it up. It's +1 when bonded to non-metals, like in HCl, and -1 when bonded to metals, like NaH. It's the chemistry version of switching teams. Rule 5. Alkali metals or group 1 metals. These guys are always +1, no exceptions. Rule 6. Alkaline earth metals or group 2 metals. Same deal, these are always +2. Chemistry loves consistency here. Rule 7. Halogens or group 7. Halogens are usually -1, unless they're paired with something more electronegative like oxygen. Then they lose their thunder. Rule 8. Sums of oxidation numbers. In a neutral molecule, all the oxidation numbers must add up to 0. In a polyatomic ion, the sum equals the ion's charge. Math saves the day at last. And finally, Rule 9. Transition metals. These are the wild cards. Transition metals can have multiple oxidation states, so you'll either be told what to do, or you need to figure it out based on the context. More on transition metals later. Now let's try and put these rules into action. Here is a chemical compound, H2SO4 or sulfuric acid. Firstly, hydrogen is bonded to nonmetals, so it's +1. With 2 hydrogens, we got a total of +2. Oxygen is doing its usual thing at -2. With 4 oxygen, that's -8. Now sulfur is left, so it must balance everything out to 0. A quick calculation shows us that for everything to sum up to 0, sulfur has to be +6. A little pro tip here, it does make sense to remember that sulfate has a charge of -2, so sulfate has the oxidation number of -2. Looking at sulfuric acid in this way simplifies it to H2 +1 and SO4 -2. Now let's try a classic redox reaction as an example. Zinc plus copper sulfate reacts to zinc sulfate plus copper. In order to find which element gets oxidized and which gets reduced, we should start by finding the oxidation numbers. Since zinc, Zn, is alone, it has the oxidation number 0. On the product side, zinc is now paired with sulfate. Remember, sulfate has the oxidation number -2, making zinc +2. So zinc lost 2 electrons and has therefore been oxidized. Likewise, copper in copper sulfate is +2, but in pure copper, it's 0. It gained 2 electrons and therefore has been reduced. You can remember this rule with the acronym OIL-RIG. Oxidation is loss, reduction is gain. Easy, right? Now let's break that redox reaction into half equations. Firstly, we learned from the oxidation numbers that zinc lost 2 electrons. So zinc reacts to zinc 2 plus and 2 electrons. For our final example, we're going to look at a transition metal compound, iron 3 oxide. The Roman numeral tells us that iron's oxidation number is +3. We also know from our rules that oxygen is -2. So how do we find the formula? If iron is 3 and oxygen is 2, we need to find the lowest common multiple, 6. In order to get to 6, we need 2 of iron and 3 of oxygen. So the formula must be Fe2O3. Nailed it! And there you have it, oxidation numbers explained. They're not just for redox reactions, but can help you to understand any chemical reaction. Remember the rules and you're golden. Got more questions? Check out my blog for extra practice, link below, and don't forget to subscribe for more chemistry breakdowns that actually make sense. See you next time, stay curious and stay awesome!